Welcome to Maths with EJD. In this video, I'll be talking about an application of binomial series, talking about simplifying algebraic expressions. Two videos after now, I'll be talking about something like that for different real life applications. So let's go for this, simplifying algebraic expressions as an application of binomial series. Okay, so we need to remember again that the binomial expansion breaks down. So it breaks down powers. It breaks down powers of binomials into polynomial forms, like we've been seeing already. So by doing that, it makes making complex expressions manageable, making complex expressions manageable. Okay, so let's remind ourselves of the key formula. We've used it a couple of times. We've even done the derivation. So key formula, that's the key formula of the binomial theorem itself. Binomial theorem. So we've used the formula a couple of times. We've even derived it. So a plus b raised to power n is summation from k equals 0 to n of n combination k, a raised to power n minus k, b raised to power k. So that's that. Now, can we use this now to deal with a situation? Imagine this example. Imagine this example where we need to expand 1 minus 2x raised to power 3. So that's what we need to do. And of course, just like we already know, by now we have all the tools we need. We have 1 minus 2x raised to power 3. So we can use the formula, right? Just like what we've done now. And that is simply this. We have this will be summation from k equals 0 to 3. N now is 3. So to 3. Then we have 3 combination k. Then we have a in this case is 1. So you have 1 raised to power 3 minus k. Then minus 2x, that's the other time, raised to power k. That's what we have right there. And then we have this to be, so if 1k is 0, for instance, we have 3 combination 0, then 1 raised to power 3 minus 0, that is minus 2x raised to power 0. That's the first term. The second term will now be 3 combination 1, then 1 raised to power 3 minus 1 now, that's 2, then minus 2x raised to power 1, okay? And then again, we have 3 combination 2, 1 raised to power 1, that's now 3 minus 2, that is 1. And then we have minus 2x raised to power 2. And lastly, we have 3 combination 3 into 1 raised to power 0 now, then minus 2x raised to power 3. So we try to tidy all of this up now. 3 combination 0, of course, is 1. 1 raised to power 3 is 1. Then minus 2x raised to power 0 is also 1. Plus 3 combination 1 is 3. 1 raised to power 2 is 1. Minus 2x is minus 2x. Then 3 combination 2 is also 3 because, I think there's this formula that, say, if I still remember, that's n combination k is basically the same thing as n combination n minus k. All right. So that means that if we have 3 combination 1, it's the same thing as 3 combination 3 minus 1, which is 3 combination 2. So you can see that's why 3 combination 1 and 3 combination 2 are exactly the same. Okay. So that's just like an aside. Then we have 3 combination 2 is 3. 1 raised to power 1 is 1. Minus 2x raised to power 2 is 4x squared. Then 3 combination 3 now is 1 again. 1 raised to power 0 is 1. Minus 2x raised to power 3 is minus 8x cube. Okay, so we can get all the terms. So 1 times 1 times 1 is 1. Then this is minus 6x. Then next you have 12x squared. And lastly, we have minus 8x cubed. And that is the expression right there. Okay, so that, I mean, that's us applying the formula. But now, we are talking about using it to simplify algebraic expressions. Now, let's take a situation like that. As we look at example, okay, let's look at a use case. I think that's a way to go for that. So we have a use case. So what's the use case for simplifying algebraic expression? So we can see that partial expansions, partial expansions are especially useful. They are especially useful when when higher order terms and higher order terms are negligible. In some cases, higher orders are just so very small, so we can forget about them. So imagine, for example, expanding only the first only the first three terms, only the first three terms of 1 plus 3x raised to power 5, can simply give us something like this. Of course, let me use the formula still. So you have 1 plus 3x raised to power 5, and we don't need all the terms, just in the first three terms, because after the first three terms, all the other terms following are just negligible. Now you see the power, when the power was 3, right? When we had power 3, we had 1, 2, 3, 4 terms. So here now, power 5, we are going to have 6 terms if we expand everything. But thankfully, we need just the first three terms, because anything beyond that is negligible. So in this case, if we apply the formula, we have summation from k equals 0 to 5 now, then 5 combination k, then 1 raised to power n minus k, then 3x raised to power k, right? But we need the first three terms, and that's so beautiful. So we just need 5 combination 0, 5 combination 0, which is obviously going to be 5. And then we have 1 raised to power. Okay, I mean, this actually should be 5 since we know n already. So this is 5. Okay, so this is 1 raised to power 5. Okay, then 3x raised to power 0. That's the first term. We need just three terms. And we have 5 combination 1 into 1 raised to power 4, then 3x raised to power 1. Because at every point in time, 5 plus 0, 4 plus 1 should add up to the highest power 5. And then the final term we need is 5 combination 2, then 1 raised to power 3, and 3x raised to power 2. Again, 3 plus 2 will give us 5. So you can see we don't have to go further. So of course, since we are just getting 3 terms, this is an approximation, right? So we can have all the rest going like that. So we just need the first three terms, so we are good. 5 combination 0 obviously is 5. Then 1 raised to power 5 is 1. 1 raised to power anything is 1. 3x raised to power 0, that's anything raised to power 0 is also 1. Then for 5 combination 1, right? That 5 combination 1 is 5 factorial over 1 factorial, 4 factorial. Oh, sorry. 5 combination 0 should be 1. Sorry, that's my bad. Uh, hope I didn't make that mistake. Oh yeah, 5 combination 0 is 1. Sorry. So 5 combination 0 is 1. Then 5 combination 1 is 5 now. So we can see from here. Then 1 raised to power 4 is 1. 3x raised to power 1 is 3x. Plus 5 combination 2. 5 combination 2, that's 5 factorial over 2 factorial, 3 factorial. I think that should be like 10, because this is 5 times 3, times 4 times 3 factorial, which cancels out, divided by 2 factorial, which is 220. That's simply 10. So we have 10 into 1. 3x squared is 9x squared. Okay, that's 9x squared. So all this can go. And then we have this now. So we don't have to go all the way. So 1 times 1 is simply 1. Then this is 15x plus 90 x squared. And that is just an approximation because that just continues like that. But anything beyond these three terms are not necessary. And so because of this now, we have a simpler form of what would have been a longer expression. And that is the beauty of binomial series. So it helps in this kind of approximation. So now we have what we need, right? So we can see that this simplification is common, is common in solving equations. Okay. Solving equations, it's common in calculus also, and approximations in physics. In fact, we're going to see a physics approximation after this video, I believe. So, an approximations in physics. So you see that this can be quite helpful. So with this, I come to the end of this video. Watch out for another application. That's physics applications, just like I said. Just like we just mentioned now. So if you have not subscribed to this channel, be sure to do that right away and hit the notification bell so you can always get alerted each time a new video is released. And don't forget to like and share so that more people can have access to this. Then, of course, comment, let me know how helpful these videos are, and let me know if there are topics or problems you'd like me to attend to. Till I come your way again, keep doing maths right. Bye.